Do not pull. Nothing happened. Alright, here's what we're going to do. We're going to solder some terminals on here. We're using large connectors. I did one to make sure I could do it without having something really bad happen. And so let's do another one together here. This is going to be a tough gig right here because I just got no idea how to keep this in focus for you. But here is my soldering fixture that I came up with. G10 again, remember it's also, this is FR4 G10, which makes it also highly heat resistant and flame resistant. Thing is, when you're soldering something, have you ever been soldering, and let's say this is your wire right here, and you're holding the thing out here, and everything's kind of swinging around, right? And you're trying to push on it hard enough to get some heat in it, and then you let go and it wiggles for a while. Okay, that'll probably work, and when it sets up, you're probably okay, but it should be left alone as it sets. So here's my ultra high performance technique for having a surface for it to sit and hold still on. Okay, we're just running this through. Little holes here. Holes are way too big. I'm really not excited about these. There just has to be a better way, but for now, until I figure out a better way, I'm monkey see, monkey do. This is what the guys are doing. This is what I'm going to do. I've always believed that the best way to have a good soldered connection is to first have a mechanical connection. Like you would crimp it onto the wire and then you run a little solder in it where the solder is actually just insurance. I would prefer that. However, I don't have that luxury on this, and I'm not going to bother trying to find some different connectors. So here's how we're going to do it. I'm trying to get this busted off of there. Did you know solder oxidizes over time? If it's been sitting around for a long time, grab you a little 3M pad and just kind of knock that stuff off the top. Ain't no reason for me to put oxidation down inside there, right? Grab my favorite gun. What we're going to try to do is make this brass hotter than heck, and then start running solder in it, and I'm counting on the solder hitting that wire and heating the wire as well. If I had a good mechanical connection, like I wish I had, that wire would heat at the same time. However, it will not. Okay. We're not going to get crazy and start running it in there till I see, you'll see the solder creep into place when the surface is plenty hot. Okay, I've now got solder laying on that wire. I kind of want to see that wire react a little bit. Okay, it just did. And then we'll put a bunch more in and we'll let go and see how that's going to hold still for me real nice there. This one, that first one, I got so carried away that solder ran around the outside, which is not a bad idea. In fact, I didn't quite fill this one. Now I'm going to reheat it. Because see how that, I don't know if you can see the wire hanging out there. I don't know if you can see anything at all. The wire's hanging out the end here, and that's a perfectly acceptable area to be soldering on as well. The more connection area I can get, the better. I have no idea if you can see that. I'm going to try to point to it and try to get in close. Right here, the wire extends out the end just like here, and I'm now soldered a little bit on the outside. Ooh, I jiggled it and I saw that solder moving. Don't want that. We're just going to wait there a moment. Don't get in a rush here neither. Every time we get ourselves in a hurry, we screw stuff up. Okay, I'm touching it. It is set. It will no longer maneuver, and so that'll be just fine. Pardon me. Something in my throat. And it's not food, and that's a big problem. Same thing, we're just trying to get it hot. Boy, you need a good soldering iron. I don't know what this thing is. Let's see. 150 to 400 watt. That's a pretty well a butt kicker. Your classic little bent wire type unit is not going to do this. You can flame do this, but that's hard to control. And you'll typically have a minor disaster on your hands. I'm waiting to see a reaction from that wire. Okay, there we go. By that I mean I'm looking for that solder on the wire to noticeably change. It'll kind of become shiny as the solder melts. Okay, there we go. I'm going to leave that alone for a minute. We're going to talk about some other stuff. You're wondering, you're probably not wondering yet. This, of course, is our ESC. You can see that you can put shrink wrap over these. This was already done by someone else. I got this used because I'm just kind of experimenting here. But when you get one of these, I assume these wires will be bare and you'll be putting your own ends on. And part of me is really hurt by this because I want to see how good a job they did in their soldering it on. But I can see this has been run a lot, that there has been no heat in these connectors, and so that's a really good sign that this is very well done here and they're appropriately sized. In one of my other videos, maybe it was this one, I showed these ends where they're discolored and have obviously been getting hot. Now it's not at the base where like the connection is bad, it's in the actual fitting, so this whole thing has been getting hot. We are going to replace these with larger units so that I have more surface area and therefore better connection. Okay, we're good. So, what I was starting to talk about is how you're going to stop these things from shorting together. Okay, we're going to connect them on here and they are going to want to short together. Here's how we're going to do that. No, I'm going to wait and show you later. It's pretty cool. I do have a couple of options. Certainly you could try to wrap, I guess we will talk about it. You could try to wrap shrink wrap over it and it would look really tacky and probably not work very well. Or, this stuff is cool, liquid electrical tape. It is basically a kind of a liquid plastic. It smells really bad, so you know it'll kill you, and that means it's good stuff. So don't breathe a lot of it. But you would coat this, and we may yet do that on the back side here, but you'll see why that really isn't going to be necessary in the way we're going to hook this up. But you can coat it with this, being careful not to coat any of the area that you need to make the contact. And then you wait about 5 minutes and put on another coat, wait about 5 minutes, put on another coat, and build it up that way. Okay, don't wait a whole lot more than 5 minutes. You want to wait until it just tacks off real good and then put another coat on. And then it's a good, boy, it's overnight before it's really set well. But I think that's a pretty good option. I've never used this in an area where you're going to be messing with it a lot, so I really don't know how good its long wear properties are. But we may be finding out. No, I'll show you right now. You got to see this. Here. I will need 3 zip ties and a pair of flush cutting wire cutters. Are you ready? I mean, you're gonna just think this is the greatest thing ever. Stay with me. You figured it out yet? Oh yeah. Come on. Oh. Get on there. Come on now. Hey, you try to do this on the live video. Oh, you're starting to figure it. I can tell you're starting to dig it. Starting to dig it. Let's see. We're gonna get up here on the connector. I almost went too far already. You might not be able to see it, but I'll at least show it to you when it's done. Okay, setting them pretty darn tight. There we go. You know, if I really wanted to get all kinds of crazy on this, I'd grab a pair of wire. Well, let me show you. There's a way you can tighten these up really nice. I think I might do it. If you really want to crank a zip tie down, you're going to hold a screwdriver against the back right here. Grab this, twist. I heard it click. You probably didn't. Just like that. And you'll get like one more click out of the thing. And then she's tight. Boy, those flush cutters are awesome. Takes that sharp edge right off. I don't think I need to tighten this one anymore. Maybe a little. Okay. Just like that. Now we have spacing all the time. Will they be close? Sure. They gonna touch? Nope. Okay, get the idea? Cool, huh? You see the mistake though? It goes in the boat just like this, and I should have put this end down so you wouldn't see it sticking up. You know how bad that hurts me? It hurts me so bad that I'll wind up cutting all this off and moving that. I thought I was doing it the right way, but there we go. Yeah, see, kind of a cool look there. I'll probably go ahead and take some of this and coat the back side of it, right? Just so that, I don't know, that does kind of have a Terminator look. Maybe I'll leave it like that. But anyway, okay, that's got those done. Let me get set up, and we're going to change the ends on our batteries to the larger 8mm over the 6mm. And we're going to change the ends on here. Okay, here we go. I kind of think I have a way to do this decent. Like with all of these connectors, I'm just not super happy with them in general, just on account of that no physical connection thing. So I've changed this one. Now we're going to change this one. And I better get the right connector out. Tell you what, I got this one ready. We'll set that battery aside. We'll do this one. I've already done the female end on this one, coated it with a little bit of that liquid tape, as they call it. Still a little bit gooey, so we're just tucking that out of the way. Woo! That baby has been hot. Losing power. Losing power. I know where to put that. There we go. Okay. Wiring looks decent. Here's what we're going to do. We're going to tin both items. We're going to put a little bit of solder inside this guy. We're going to solder this guy. I find that these wires are really unfriendly. They don't like to take solder. There is probably a better solder to use for this. In fact, I would really appreciate it. Why don't one of you guys, or two of you guys, or 57 of you guys put a comment. Let me know what you're using on this. I don't care that it sticks out a little bit. Can you see that it doesn't go all the way in? We're going to coat that. That's fine. You'll see in a minute why that's actually a useful thing. Pardon me. So first thing we're going to do is work on tinning the wire. This might be enough solder to accomplish that. Better buy myself some room here. I'm going to need those pliers in a minute. World's greatest soldering iron. It's plenty hot right away. See, you'd like to see this take solder and see it just go taking off and running down inside this wire. And it just doesn't do that, which is an indication that it's unhappy about something. It could be that I could actually use the silver bearing solder on this and maybe it would be happier. I do not know. But you're going to tell me, and that'll be super helpful to me. This solder is getting pretty short, pretty hot. See how I did that? Nice and quick. A lot of excess. I'm just shaking it off. Shake it off, man. Don't worry about it. Just shake it off. Okay, you might look at that and think that it's pretty good. It's probably not. Let's flip it over and look. Okay, see, it didn't run into the backside. So we're going to work on it all the way around. And the reason this really displeases me is since we do not have a mechanical connection, we cannot count on actually using all of these little strands. We're only going to be actually taking advantage. I don't quite know how to term it, but the most effective ones are the ones that are going to have solder on them, because then they are directly connected. So the wires up inside of here, let me shake that a little bit, hope it doesn't go in my eyes, probably don't have solder and might not be doing us any good whatsoever. So I will continue to work on this, and I will try to find a better way to do it. Meanwhile, we carry on. Oop. Oh, that's going to be getting so hot. Come on. Serious now. I want you out of my way. Let's try this. Maybe I can go in through the hole. And you're going to make fun of me because I'm going to get solder all over the outside of this thing. And I don't care. I'll show you how we're going to deal with that before all is said and done here. Now, just like doing our other wires, you need a way to make the thing hold still. So that's why I have my super high-tech fixture here. Trying to move somewhat quickly, while I still have some heat down inside this wire, because that's really the key. The same reason that the solder doesn't take into it really well, because it doesn't heat really well inside, is the same reason that it bothers me that we won't get really good connection out of it. I'm going to push the battery a little bit to hold a little tension on that end. If the heat doesn't transfer, that's the same thing. The little electron boogers aren't transferring really well neither. Okay. Nobody move. Let it set. You can see I got a whole bunch of solder. Maybe you can't see it dangling down underneath. I'll show you that in just a minute here after it sets. It won't take long. Hopefully. Okay, it is set. Waiting another second or two here. I'll take a look at this meanwhile. Can you see that? A little liquid tape on there. It's really nice. It's worth doing, you know, as I thought about it. I don't know if you've ever noticed, but solder tends to, well, I already told you, it does tend to oxidize, but water amplifies that really badly, and it'll begin to corrode. And you'll get all this surface crust on it, and it's just bad for connections. And that corrosion just kind of travels, and it can travel all over everywhere. So we want to just eliminate that. I probably could have shown you that. I would be willing to bet inside that connector we just cut off. That would take me some digging to get down to it. But if we dug down to it, you would find where that solder attaches to the dissimilar metal, it'll corrode around there. And this one looks like it was sealed up really well. I did pull the insulation off of one of the black ones. It had just a whole bunch of corrosion laying on the solder. Okay, there we go. This is why it doesn't bother me to have this extending a little bit, because it allows me to see the wire, and I can see that I am soldered to the terminal all the way around the wire. Remember, I want as many connection points as possible. If there's anywhere that we didn't get solder on it, we want to solder that up. But we can take care of this goober here pretty easily. We can leave it there because it's harmless, or we can pretty it up slightly. Now this is 40% lead, guys, so don't be sucking on this. And if you got a big old giant goober, you don't want to be sanding that for a long time. Cut it off or something. There you go, goober's gone. I'll go ahead and show you the liquid tape scenario here on this one. How hot is it? Oh, look at that, cooled off pretty quick. This stuff skins really fast, okay? So you don't want to leave the can sitting open for a long, long time. So work quick. And you can slap it on there pretty heavy. Don't be bashful. We want to get on the wire. Okay, I'm sorry, on the insulation. Because we are trying to cover everything. We're going to keep water out of this solder joint. Okay? As well as covering it for the obvious zap, zap safety reasons. It's got to be terrifying if these terminals come together. And remember, more than one coat, so even if you do find some bare areas, after your first coat, it's not that big a deal. I'm trying to get it even up on that, just that little ring area. Why? Because I need to? No, because it'll look really cool if I do it successfully. And I got some on my fingers, which is a given. Starting to skin. Once it starts to skin, it starts to get a little bit sticky, and it actually lifts itself right back up. So there's a spot there that I didn't get, but I've got to let it set for a minute, let it kind of stick to the material, and then the next coat can go on there, and that'll cover all that. So that's how that works. What the? Now what? Some of you have asked, so let's talk about it. Here's what we're going to do. We're going to just kind of simulate our boat while we put our electronics together. So you've got your motor mount built, you've got your motor all set, you put connectors on. You put connectors on your ESC, and that all kind of makes sense, but which way do these go? You know what? Nobody knows. No kidding. You're going to connect these three, okay? 3 out of the motor with the 3 coming out of the ESC. You've got 2 coming out of the other end, all right? Disregard. Does not matter how you connect these. Now, when all is said and done, once you're programmed and you fire it up and you hit the throttle on your transmitter, if the motor spins the wrong direction, you can do one of 2 things. There's programming in the ESCs that you can do, and the manual that comes with yours will tell you how to do it, and you can reverse the motor rotation. Or if you don't want to mess with that and you've connected it and your motor's going backwards, all you have to do is disconnect 2 of these wires and reverse them. Okay? No, I do not know why, but it works. All right? Something to do with these brushless 3-wire motors. If it doesn't work, it doesn't matter which 2. You just connect and you swap them. If all goes well, I would like these 3 wires that come out real nice and these 3 wires to just connect like that and have it go in the right direction. Right? Wouldn't that be cool? We're going to find out. So, you connect these 3. Let's just shove a couple of them. Man, we'll shove them all in there. Even though they're really not ready yet, and I'll show you why in a minute. Okay, and that's going to mount about like that. These will be like this in the boat. Now what do? I got lots of extra wire here. Okay, here's the deal. You're going to take negative from one of the batteries, and you're going to connect it to the positive of the other battery. And here's what happens. You probably know this stuff. Okay, we're looking at DC voltage. This battery is 15.73 volts. This other one is going to be similar, 15.9. We're going to connect the black wire to the red wire. And now, here is now your positive and your negative to go into your ESC. And we have done that so that we double whammy it. Look at that, 31.6. Holy schmoly. So right now, it's perfectly safe. We're going to connect our negative wire. And this is how you'll have it assembled in the boat. Okay? In between heats, everything sits like this. When you're ready to run, you connect your last red one, or the last black one. It really doesn't matter whether you have the red already connected and your black is your final, or your black is connected and your red is your final. And then you're ready to run, except, of course, you still do have to run a receiver. And in my case, I also need to run a receiver battery. Now you can buy ESCs that have power automatically given to the receiver through the wire when you connect these batteries. This ESC does not do that. That's a cool way to go, and I will do that in the future. But this is what I have right now, okay? So this, oh, you notice you have two wires that look like both of them are supposed to go to the receiver. They are not. This one is used for programming, the short one. The long one goes to the transmitter in your normal throttle location. All right? Which in this case is the second connector. And now, to turn this thing on, I don't use switches anymore. Here's how I deal with it. I am just going to connect the battery and she'll be ready to run. Now I don't want to connect the battery straight into the receiver, mainly because I just don't want to be connecting and disconnecting these terminals over and over, okay? So what I do is I use a short little jumper lead. This guy lives on there all the time. And now to power up my boat, I connect this one and disconnect. And once a year, anyway, I replace my receiver battery. And at the same time, you'll replace this little pigtail. So this connection you'll only make once a year. This connection you're connecting and disconnecting, and then eventually you throw it away and put new stuff in, okay? So that's it. When you're ready to run the boat, you power up your receiver, you make this connection, and the motor is supposed to make all kinds of pretty little doodly-doot noises to tell you that it's ready. Hit your throttle one time, zing, make sure it spins, ready to rock and roll. Okay? So that's how it works. Now, let's put it in the boat. I almost forgot to show you this part. We're going to talk about connectors. Specifically about preserving connectors and improving connections. I've mentioned in some of my videos dielectric grease. This is an old tube. One of these tubes will last you a long time. I don't know if you can even read it anymore. Dielectric, just the way it sounds, D-I-E-lectric. Dielectric tune-up grease. This is different than regular silicone lube, okay? So you're not just going to jam regular silicone lube. Go get some dielectric tune-up grease, Loctite. You can buy this in much, much smaller little tubes, but get a bunch. You're going to put this everywhere. I am not kidding. You wouldn't think that you should put grease in electrical connectors, but you should. You're going to get some of this and put it in every connector. This will keep it from corroding. It will improve the connection, and it'll make it easier to assemble and disassemble quickly. I recommend you not touch these two together. Just as a suggestion. Okay? Now we're doing that with everything. You are not going to be able to tell on this video. These are used batteries, you can probably tell. This connector, there's a bunch of corrosion on the terminals inside there. This is what you're plugging in to balance while you're charging this thing. There's a little tiny fly zipping around here. This is no good, man. The water's doing this, you know, it just kind of eats it. harmless, you know, because this has nothing to do with connecting power on the boat, although this does need to connect properly when you're charging. But put this stuff everywhere. This stuff's going in the water, dude. If you're an old guy like me and you used to pack wheel bearings, that used to be a thing where you'd have to pack the wheel bearings on your car. You still should be doing it on your trailer. You guys that have smoked bearings out of your trailer going down the road is because you haven't been packing your bearings. This is largely why I don't use switches anymore. Number one, I don't want to add the extra weight. Why should I put a switch on if I don't have to? Number two, how many times over the years have you seen a boat smack the beach? They say, oh, what happened? Oh, switch went bad. Well then, why are we using them? You go build something. We're going to put this boat together. See you soon.